I think what's really driving Hudson is this undeniable economic trend that is the computers are getting cheaper and cheaper price-wise, given the same functionality, yet we, the developers, are getting more and more expensive because of the inflation. So the simple law of economics dictates that it makes more sense to spend more money on computers and less on people to achieve higher productivity. And while the Moore's law might be hitting ceiling, I don't think there's any reason to believe that this trend is going to change anytime soon. So I think that's really sort of, in a way, pushing us toward this direction of using more and more CPU powers, the computing capability, to make us more productive. I think in the past, this has been mostly happening on your IDE. So I think nowadays, I can see my IDEs using a couple of gigabytes of memory for building the very complicated data structure so that I can do all kinds of things like data flow analysis on the fly or some sort of the error checks all done while I'm editing, even before I'm running anything. But the single computer performance, unfortunately, is somewhat saturating. So I think what's happening nowadays in the software development is that we need to be able to use more and more servers, the back-end servers that doesn't sit in front of you to make you more productive. And I think that's sort of the underlying trend that's going into the continuous integration. In a way, this is sort of like super anti-echo, that is, we are wasting heat and generating and it's using more electricity to run the test and build more frequently for somewhat diminishing returns. And it used to, this kind of thing used to be pretty expensive. But as we have to harness more and more computers to make us productive, I think this is one of the obvious directions that we are going. So primarily the continuous integration is about running more tests and builds, but I think we are starting to see more of this, like running code analysis tool on the server side. And then I think we just sort of started tapping into all the potentials. So I'm sort of quite excited to working on Hudson now because I can sort of do all kinds of things like these. So the Hudson is a particular implementation of the continuous integration server. I think it's done on the hudson-ci.org. It's open source. One of its key emphasis is placed on the ease of installation and the ease of use. The tool like this is sort of entirely designed to make you more productive. And as a person who writes code by myself, I know for sure how painful it is if the tool sucks. It could actually waste your time more than it helps. Like let's say Maven or something. And I hope you don't mind my saying that. But so the Hudson is packaged as a WAR file, but it can be also started just like any Java-C application. But since it's a WAR file, if you know how to manage the application server like Tomcat, then you could just deploy Hudson on it and it gets going. Or if your system administrator is not really a Java guy, then you could ask him to deploy one of our operating system specific, the native packages like RPM or Debian package or MSI installer. And in that way, you could have your administrator or the IT operation guys get it installed for you. And once you install it, you can configure everything from the browser. So that's one of the key benefits of Hudson, as I hopefully be able to show you in the demo. Another emphasis in Hudson is its extensibility. So I think we wanted to take the full potential for being open source. So I put a lot of effort into making sure that it's extensible. It comes with some development environment built around Maven and so on, and the update center so that developers who wrote the plugin could deliver their bits to the users, and the users could just grab the stuff from the update center without worrying about how to install them. So today we have more than 230 plugins that's developed by the community that integrate Hudson into all kinds of different things. And the Hudson as a whole, including plugins, has been developed by more than 230 contributors. So it's quite an active project. And it's also got some sort of the usage statistics capability. So we kind of currently estimate around the 13,000 installation out there that's been running for a substantial amount of time. And then it's been used in all kinds of places. You can certainly expect this kind of software to be used in the software industry, but I find it to be used inside like the government agency, the financial sector, or the railroad companies, or the European Space Agency, and all sorts of places, which I didn't expect to be writing source code. So it's been, it's been quite actively deployed, and I think I could be able to say it's a fairly proven software at this point. So the community releases happen. That is, this open source version releases every once a week on Friday, and I think I have currently I'm at 1.345, which is pushing the limit of version number, what it means to be a version number. But so this rapid pace of release allows us to deliver new features and bug fixes quite quickly. So I think it's been very convenient for us to be able to sort of, people drop by on the users list and tell us that, oh, this and that is not quite working, and we can fix it right away and turn it around within 1 week. So that's been rather nice. And on top of that, but this sometimes it's too rapid for some enterprises to continue. So, to keep up with the pace. So for those, the Sun has the commercial versions that's geared more for the stability and so on, and it provides the bug fix only releases for 18 months. For those of you who don't know Hudson, I guess at the basic level, the Hudson or any other continuous integration server for that matter sort of works in this way. That is, first, it looks for changes in your source code repository, and then when it detects a new change, it checks out the source code, and because the world has too many version control systems, this is one of the places where the community has really stepped up to write a lot of plugins. So chances are whatever version control system you're using, we probably have a plugin for that. And then once the source code is checked out, we sort of do quote-unquote builds. And this could mean any number of things depending on the kind of project you're working on. Or sometimes it's not even just the builds, but it could include tests or some sort of batch processing of kind. So again, there is all kinds of tools people use for this kind of thing. So that's another place where we developed a lot of plugins. And once that is complete, the next step the Hudson is going to do is to sort of keep the record of what happened inside the build. So this could mean things like keeping the result of the build in somewhere safe, or it could mean parsing the test reports so that it could send out some notifications. And that's the final step, that is to send a notification. Because if the program develops, all Hudson can do is sort of call the attention of the people. Unfortunately, it's still not capable of fixing the programs on its own, although we are working on it. So again, we have a number of plugins in this space to sort of let people engage people in a way that doesn't annoy them. And on top of those, there are different kinds of tool integration, like the static code analysis tools. That's one of the very common things that the people use, or the code coverage. These often take a lot of time, and it benefits from having everyone seeing the same report, as opposed to letting individuals run them and look at reports. So that's why it makes sense to do this sort of thing inside Hudson. So I've already downloaded Hudson here, just so that I can save the effort. Well, in production, I'd be probably deploying this on Glassfish or something, but for now, for the purpose of demo, I'll run it on the console. So it comes with embedded servlet server to start, and then this is the UI. I think hopefully this will be big enough to see, although it breaks the layout somewhat. So let's create. I also had, since this is a toy example, I created a small Subversion repository on this laptop so that I can show you. So let's create some Ant project. And then I choose the freestyle project, which basically means I can pick and choose whatever I want. So this would check out from Subversion. I think it's well, I guess I'll just cheat and look for the values here. So one of the benefits of having the GUI as opposed to editing the XML file is if I make some mistake in the configuration, it sort of performs all the kind of checks behind the scene right away, and I notice it. So detecting a problem gets much more quicker. I mean, it gets much faster. So I'll check out from the subversion repository, and this is like a trivial ant project. So next I'll invoke ant and execute like the install target and test. And let's see if I could get something going with that. So I'll manually start the new build for now, and it sort of gets going. I think this one went too fast, so I didn't actually see the build going, but in the realistic example, you'll see like the build progress as, I mean, you'll see the output coming out from the build as it comes. So let's see. So I probably should keep some records of what happens. So maybe I might choose to archive the jar file that's created out of this build, or I might look at the test reports. So again, if I make like some mistake in the file name, and it's sort of checking this with what's already built, and it's telling me that, oh, there's no such thing as built too. So it's probably like a, the typo or something. So now, yeah, also I guess it's not very interesting to like manually trigger a build, because I mean, you're not going to be doing that in production. So let's see, I could build like periodically by using some cron syntax. So maybe I might want to build every 5 minutes, which might be a bit excessive, but should do. Or I could pull the version control repository so that I'm only building it like every time when some change happens. So this is, I guess, another thing that I think people often find useful is to be able to see all the inline helps. So you can see the syntax and so on, or what it means in all the gory details. So almost everything comes with those. So I save, and I guess to make sure that this polling is working, let me break the test here. So I have two silly tests here, so maybe my change is to modify the test case so that I break out test. Let's see. So it's going to be picked up in a minute at least, and then we should be seeing build number 2. So in the meantime, you can, for example, in Hudson, you can see the workspace that Hudson has been checked out. So often I find it useful if I'm talking to someone over the phone about some issues in the source code. This gives me some URL that I could paste into the instant messenger to talk about the same thing. Or I could, let's see, what else can I do here? I can also look at the list of changes that went into each build, and so on and so forth. So, and I guess the build number 2 has finished. And now because I broke the test, so it correctly recognized that I picked up the change that I made in the repository, and it also detected that I had one failure. So, so that's the kind of thing that generally Hudson can do. It's sort of most people. The very typical use case is just like this: that is, you run the build and test and make sure that the tests don't break, or if they do, you get some details about why it's broken and so on. So that's about the configuring the ant project, which is, hopefully it wasn't too much configuration, but it's nevertheless you still have to tell Hudson where to grab the jar files from or where to pick up the test reports. So another thing we do in Hudson is, since I use Maven a lot in my day job, and I think many of you might, I have some additional the support for Maven too, because in Maven sort of brings some rather strict uniformity of the build. So without you telling Hudson where exactly are test reports, Hudson sort of can ask Maven where the test reports are. So it kind of saves you the configuration overhead. So if I do, so I still have to compute I still have to tell Hudson where the repository is. But if I do that, and then, I guess I need to tell Maven what goal I want to run. So maybe I want to create the Java doc and install. Then notice I didn't tell anything about where the test reports are or where the Java files are. But because the Hudson knows that you're doing Maven build, it could pick up all the details from Maven. And in that way, be able to capture all those data automatically for you. So let's see. Oh, I guess it has completed. So you can see the test reports. You can see the Java doc here. You can see the list of modules in this build. This is the generated Java doc. So I guess that's basically what it can do. It's Hudson at the very basic level. And I thought I'd briefly mention, like, why do you care about this kind of things? And so I thought I can probably tell a better story by explaining why I felt like writing Hudson in the first place. That is what motivated me to do it. So one of the issues, so back then, before I do Hudson, I used to work on the JAX BRI, one of the reference implementation for the JSR. And maybe I had like 4 or 5 people in the engineering that's distributed and writing code on the same repository. So I used to be like the guy who forget to commit the file. So if I'm lucky, well, so I forget to commit the file. It's not Dev, it's me, I guess. I forget to commit the file. And then if I'm lucky, maybe one of my colleagues would notice it within a few hours when they try to update their local workspace. But if I'm not so lucky, it's not going to get noticed until the nightly release that's done by the release engineers that's in a separate group. And if the nightly build doesn't run correctly, then it wastes more time or more people, because in the next day, the SQE, the different team that runs the test, cannot run the new test. So we waste the whole day. So by writing Hudson, well, the Hudson can tell me if I forget to commit the file in 5 minutes. And hopefully that's way before anyone else update the workspace. So I don't get to do the credit, and I could fix the problem silently without anyone noticing it. So that's one of the obvious benefits at least. And since I started deploying this in production, I discovered that I'm not the only guy who forget to commit files. It's that everyone was doing it, but I just wasn't noticing that everyone else was also having the same problem. Or another similar use case is that if you make a change in your source code repository to fix some problems, let's say in Monday morning, and then it is often the case, because if you only run nightly builds, the official build is going to only happen that Monday night. And so the official test execution now is only going to happen like that Monday night. So the earliest people can come into the office and see the result would be the Tuesday morning, right? So, and then let's say if the fix didn't work, then you have to work on it Tuesday morning, and so on and so forth. So as you can see that it's sort of, in this way, the time it takes from the bug to show up to have it getting fixed kind of spreads across a longer time. And so that means you're likely to have more than one bugs on the source code repository at any concurrent time. And also humans are not very good at doing context switching. If I made some fix yesterday, I might not remember all the gory details or the intricacies in Tuesday. But with Hudson, well, if you can run the test all the time, then the change you made on the Monday morning would be subject to the whole test execution within, let's say, 1 or 2 hours. So in that way, even the test didn't work as expected, you still have enough context in your brain, and you can work on the problem, let's say, before the lunch. So by compressing the time it takes to work on the problem, it sort of improves the productivity of people. So another issue that I had was, back then we used to run this test execution inside the cron, and I think many people would do that. And even that was considered, back like 5 years ago, even that was considered a improvement over tests being run manually, right? So, but the problem with the cron is that it can only send emails, and it doesn't really know anything about what's going on. So yeah, someone writes like a Perl script to parse the results of the test into like subject and email, and you start receiving email every once a day about the status of the test. So what quickly happens is that, if the test is passing, then you have no incentive to look at those. So you quickly start filtering them away from your brain. And so even if the problem is discovered by those programs, you just don't look at that folder. You set the filtering rules that all the emails go to. And so only right before the release, the manager notices that, oh, the tests were failing all along, and how come we didn't look at those? And everyone gets angry, and it's not very good. Right? So in Hudson, one of the things that I do very carefully is not to bug people unless necessary. So because Hudson can remember what happened in the last time, for example, it only sends out the email if the test starts to break. Right? So if everything is going fine, then you won't get any spam emails, so to speak. So that's very important to keep people's attention. Aside from some of the trivial features that I showed in the demo, some of the other things that Hudson could do, for example, is this notion of metrics project. That is, I often work on the software that needs to be tested on different environments. So what this feature allows you to do is to define a single set of build, and often it's a test, and then let Hudson run it on all the places that you need to run it on. So this screenshot I took from the JAX WSRI unit test development. So whenever we add a new test in JAX WSRI, we're going to test that against 3 major versions of the JAX WSRI on 3 platforms that we have to support, and on 2 different JDK versions. So all in all, it adds up to a significant amount of computing power. But the Hudson will be able to keep track of what's run where, and it aggregates all the results back, and then show you some tabulated view that, oh, but like something is wrong with Solaris on 2.2 or something like that. And it does happen, let's say, on NIO stuff or something where the performance, the platform difference does matter. And other people often use this for like the cross-platform compilation. If you're doing C project, you often have to build a binary on different like flavor of Unix and so on. So people have successfully used this kind of feature there. This is a screenshot I took from the FindBugs plugin, which is probably one of the most common source code analyzers people integrate with Hudson. So as you can see, the Hudson does parse the result, comprehend the result, and show it to you. Then, so one of the things that Hudson can do better than the default FindBugs report that the FindBugs itself produces is that it has this one additional dimension of the data, that is the time axis. So not only it knows that it's got the 14 warnings in place, but it's actually capable of telling you that there's one more warning. And that's the kind of thing you want to pay more attention to, because no one has a project that doesn't have any FindBugs warning, right? I mean, it's got some silly reports that it generates that contains a few of them. So what you want to focus your attention on is like when you make some changes, and if that introduces a new FindBugs issues, and that's the one that you want to work on. So by having this additional time axis of information, I think Hudson can add a lot of values to the default, the code analysis tools that people are using. So this is like the list of changes that went into each build. And what often happened in Sun, and I think it's true elsewhere, is that if you have a separate team of people testing your bits, they have to grab that bits from somewhere. And so that's often a bit lagged behind in terms of what's really in the tip of your repository. So when the test people detect some issues, often the first reaction of the developer is that I think I fixed the problem already, so can you run the test again? And that sort of really makes the test people angry, because they feel like they are sort of less respected. So one of the things that this kind of view provides you is that you can know exactly what change went into which build. And by using the other features, you can also, during the test execution, you can know exactly which build it's testing. So between those accurate tracking, you can tell what exactly is being tested at any given test execution. So I guess I've already showed you this the workspace view, which shows you the list of files in the workspace, and you can also track like the time it takes to perform build. This is more useful for tests because you often want to keep track of how long your test is taking. And then on top of that, the Hudson, so one of the key benefits of Hudson compared to some of the other earlier CI tools like Cruise Control is that it's capable of hosting many jobs on one Hudson. As I showed in the demo, I had like the 2 or 3 different ones. in my production Hudson, I have like 400 different jobs done by all kinds of people. So aside from the obvious benefit that this reduces administrative overhead, Hudson has a lot of like inter-project support in Hudson. So you could say, if there are jobs that are related somehow, then you could express those inside Hudson, and it can do all kinds of interesting stuff with them. So in that way, it sort of really adds more value to the whole thing, not just the performing build and test, but by having lots of different modules or components interplay with each other, it derives some serious value. So one such example might be to execute tests. So maybe you have one job that does the build and another one that runs tests. And then you could correlate between those two so that you can keep track of which build is being tested when. And so in that way, you can get exactly accurate result, like when the regression happened, what change caused the regression, and so on. Another feature that I'm going to talk about in a bit more details is the notion of promotion. So you have a lot of build, and you want to create lots of builds so that you can get your feedback quickly. Like if you fail to compile the program, you're going to know more quickly. So that means you'll be running more builds more often. So that means you have lots more build, and that might be more than what the other people who depend on your binary might want. So you can indicate that this particular build is promoted, meaning it's of rather good quality and it's recommended for the other people's consumption. So you could do those things. And again, you could tell Hudson to do this automatically, or you could tell Hudson that if the build is promoted, do this and do that and do something else, so that you could have more automated chain of integration. By using the fingerprint feature, you can also track which build of libraries are used where. If you are working on a big software team that consists of like smaller teams that each producing bits that's consumed by someone else, it is often the case that the program that's in the library, let's say, might be detected much later downstream, but only after it's integrated into somewhat bigger pieces. So in that sort of environment, it's critical to be able to track exactly which build of the library is being used in these downstream components, because the library guy needs that information to fix it. So that's the kind of accuracy that only programs can provide. I mean, the humans are just not good at doing that sort of thing. So you can let Hudson worry about those details. So let's see. So the first thing I wanted to look in a bit more details is this idea of test-build separation. That is, well, if you're writing a reasonable amount of tests, and I hope everyone is, then the time it takes to test the program should dominate the build time, because the build is really just like compiling things. I mean, how much time it takes to do that. So often your build takes longer if you have a lot of tests, and that's sort of like not a very good thing in terms of getting quicker turnaround time for your feedback. So what often we do, and what I often recommend to people, is to split the tests into smaller chunks and then run them in parallel. So in JAXA-BESS, for example, we have one job that performs a build, which basically just runs the Java-C and some quick tests and produces the Java files. And then, so that completes, let's say, in like 5 minutes. And once that's completed, I have a number of jobs that are designed to test the bits that's produced by this guy. So because different groups are involved in writing tests and different environments are involved in writing tests, I can very easily run the tests in parallel. Like I showed you earlier in the Matrix project, Hudson also helped you run the tests in parallel. And so all these tests start to run in parallel, and so I can get all the results done in, let's say, 1 hour on all the platforms. And then in the meantime, if I have more machines, another round of the build is continuing, so I have more quicker feedback cycle for easier issues, like if I forget to commit a file, while for the more complicated issues, like the real test regressions, I can still get the result within, let's say, 1 hour. So if you think about running everything like this in your laptop, then it's going to take some significant time. And while your laptop is doing that, you won't be able to do any coding because the CPU is so pegged to 100%. So by doing this, so this is one of the ways you can be productive by using more servers. Now, when you do that, to help you do this, the Hudson has a notion of permalink. So from the test, you can access Hudson and grab the latest binary of JAX.SRI. And by using fingerprinting, which is basically just a MD5 checksum of the file in question, and then Hudson can keep track of those checksums and where it's used. So in that way, Hudson keeps the exact record of, well, the test execution number 123 has been testing the JAX.SRI produced by build, the 56 or whatever that is. So that provides the tracking part. The build promotion, I took this from, I think, the JAX-BRI. So, so one of the issues that I discovered after we deployed this in Sun is that as a JAX-B developer, so I guess just as a background, so the JAX-B and JAX-S should be thought of like two different modules, and the JAX-S guy depends on JAX-B. So every so often, the JAX-B team needs to produce a binary that the JAX-SRI team consumes. But so we need to produce a good quality binary that's good enough to be able to use by the JAX-SRI, because the last thing we want is to have a silly bug in JAX-B that stops the progress of JAX-S. On the other hand, we need to promote and push the change fast enough, because often the problem in JAX-B is discovered by this JAX-S guy. So if they discover the problem, they are waiting for the fix. So the fix needs to be delivered quickly, but also in a controlled fashion so that it doesn't wreak havoc. So we need some sort of like a controlled way for flowing the new binary from the component to another. And it's a fairly universal problem if you have different people working on different modules that interface with each other. So the notion we came up is this idea of promoting a build of JAX-BRI. So as we were already doing this kind of split between the build and test. So one of the negative consequences of this is that you tend to get a lot of the JAX-B or JAX-S builds, which are successful just because they pass the compilation, but in practice it doesn't really mean much about the quality, right? The passing compilation is like the lowest bar you can pass. The real test is to see if it passed all the tests. And it takes it takes some amount of time for the test to finish, because tests take longer time to run. So what we can configure in Hudson is you can tell Hudson that, well, if this JAX-BRI build has successfully passed all these downstream jobs, then we can promote the build and claim that it's good for JAX-S in this case. And then I can also explain to Hudson that if the build is promoted, do this and that. So in this case, we actually grab the jar file from the JAX-BRI and commit that into the source code repository of JAX-SRI. So we have an automatic integration set up in this way, which never commits a broken JAX-B jar file. So here you can see that, I guess, this particular build of JAX-BRI had been tested by these build numbers, and then it happened, I guess, the 2 weeks ago, the 12 days ago, and that was 45 minutes after the build was completed. So it took the 45 minutes to completely run all the tests, but that's probably still rather quick if you think about the time it takes for humans to do something like this. I could easily see the promotion taking like a half a day, because it has to involve like different people reading emails and so on. But this can be now done all automatically on systems like Hudson. So that's sort of like really the basic idea of Hudson. That is, it sort of adds more automation. It brings more automation to the software development. And so in that way, it helps people focus on what it really matters, like writing code. And then it also tries to reduce the turnaround time by doing everything more frequently. And reducing turnaround time is very useful for many number of reasons. And by having a website that shows everything, it tries to make things more transparent. The managers often love this kind of stuff, that is, because they can actually go see the test reports. Not that they can really tell what's going on, but at least they can see it, right? Or the code, they find bugs. They can at least see if it's going up or down, and that helps. And I think another thing is that it sort of removes the people from the critical loop. So it often happened in the past that, if I discover some silly bug in one of the libraries that's also developed by a different team inside Sun, Now, I have to ask the guy that's writing code to tell me where the source code repository is and which branch I can commit the changes and where I get the test code and how do I run the test and so on. Now, with something like Hudson, all the information is up in there. So I don't have to waste the time of this other guy to find out those silly information. I can just ask Hudson to do it. So that's the kind of reason why I think the Hudson is making things more productive. Oh, and I guess, right, so the critical underlying trend, as I mentioned, is that the Hudson being the server app, and it's capable of using lots of systems to carry out the builds, it helps you use a larger number of computers. So I have a cluster of 30 or maybe 40 machines that's used by our group for doing all kinds of builds. If you think about doing everything inside your laptop for that kind of thing, well, it prevents you from using your workstation for things that can be only run on workstations, namely the IDE. So that I think is the critical factor. So because it's such an in my mind, it's such an important part of Hudson that you could use a lot of server computers, not necessarily because Sun is selling servers. I spent a lot of effort in making sure that the using computers, using a lot of servers is easier. Because the reality is that using lots of PCs aren't particularly hard. It's just a tedious work, right? So then that's the kind of thing that computers are good at. That is to automate the tedious but not the difficult work. So that's where we've been spending effort on. So let's say, so if you think about if you got like 24 computers lying around, and if you want to use it in some coherent way, the first step is you have to install a new operating system. So in the first 20 or so slaves, I was doing this more or less manually by putting in the CD and clicking the OK Enter key while I'm working on the code. But you can do this, and it's not hard, but it's sort of, because the installer often tends to be interactive, this takes a long time to do. So after a while, eventually we came up with this automatic solution and packaged it as a plugin so that you don't have to manually install the operating system. That's called Hudson Pixie plugin, which is the name of the technology that's been around for a long time. So the way it works is, you have, I guess I forgot to show the update center, but it's really easy to install the plugin on Hudson. You can go to the Hudson Web UI, and it, kind of like Eclipse does, just like Eclipse does, it shows you a list of plugins that you can install on your system. So you check the box and click the install, and that's it. Basically, that's it. And so in that way, you can install the Pixie plugin. And you also have to download the ISO images of the operating system that you want to install. Those are too big to ship inside this plugin. And you put that on the network. And you bring in the other machines that you want to use as slaves. The slave is the term that I use for the drones of machines that the Hudson would control to get the builds done. So you bring that slave on the network and then flag the power in the network, and then you power on and you hit function 12. And on every system that's built in the last 10 years at least, this makes a PC boot from the network. It's called Pixie boot in the technical terms. And then you'll see the menu that's telling you to choose the operating system that you provided ISO files for. And you can choose the OS, and you could choose the automatic installation for Hudson. You can also choose to do a normal interactive install if you happen to be installing desktop, so that you don't have to go around looking for CD-ROM to do that. And then it will install itself and come back as a Hudson slave. And one of the key innovations here is that this is done in a way that's very friendly to the existing DHCP server that's maintained by your IT ops guys. And when I asked them that if I could modify their DHCP server so that I could see this information, they literally laughed at me. So this was one of the key innovations, that you won't upset your IT ops guy when you do this. So once you have the lots of machines that has a reasonable operating system installed, the next step is to connect them into a single cluster. So the way Hudson does that is the master-slave architecture. The master is the one that sits in the middle. It serves all the HTTP requests, and it stores all the important informations. And slaves can come in a large number, and they are assumed to be unreliable. so they can come and go while the cluster is in operation. So let's say if you have 30 machines, chances are one of them is always developing some problems. So it's critical that you can take it offline without bringing down the whole cluster. And we also made it so that you can deploy a slave by just having 170K single jar file, and it doesn't change that much often. So it's very easy to keep the upgrade Hudson cluster because you don't have to deploy the new binary to all the machines. You can just do so on the master. And we know for sure that it scales at least to the 100 slaves. That's about the maximum that I've seen in production. There seems to be some interesting organization effects. So the upper bound seems to be driven not so much by technical issues, but more like organizational issues. That is, for you to justify using 100 machines for a build, you have to be a reasonably big team, right? Now, if you're a big team, it often happens that someone in the team has different requirements than another guy. So let's say one team wants to install the Findworks plugin like right now because they are in this quality drive mode, while the another team is right before the release, so they can absolutely never touch the Hudson cluster. So often as the team gets bigger, they tend to want to own their own Hudson cluster so that they could really lock down the system. And so that's probably why I've never really seen any Hudson cluster bigger than 100. And another thing that I think that's nifty is the link between master and slave only happens over a single bidirectional byte stream. And so because of that, it's very easy to tunnel this over many different networks. So we have some people who have very strict network security requirements that cannot open any arbitrary ports and so on. And so, or sometimes the master is behind a firewall where the slave is not, or the other way around. And we could sort of make those network shape work. So let's see. So the next step is how you can get the machines talking. So you still have to have this 170 kilobyte jar file on the slave, which I thought is more tedious than it should be. So Hudson actually comes with its own SSH implementation so that if your slave is a Unix slave, then you can just tell the machine name and the login credential. And then Hudson will be able to talk to this SSH server, copy the necessary files, including JDK if you don't even have a JRE on this system. So it's capable of installing JRE remotely and copy the files, and then it starts the necessary program over there all automatically. So really, you just need to specify the hostname, and it doesn't really get any easier than that. On Windows, starting the SSH server is a bit more work because you have to have Cygwin and so on. So I have a different implementation based on DCOM, which more or less achieves the same end result. So again, you have to tell us the host name and the username and password of the administrator. And then Hudson will talk remotely to this Windows machine, the install necessary programs and so on, and then it starts the Hudson slave. So you can install a slave without ever touching slave, aside from powering it on in the first place, I guess. So this should make it really easy to start and administer a Hudson cluster. So those two use cases can only work if the master can see the slave. But if they are behind a firewall and so on, it's not always possible for the master to see the slave. So there's a way to initiate the connection from the slave side. And this is packaged as a JNLP, so Java Web Start application. So you can come to the Hudson website and click this launch button, and that will start the necessary slave programs, and then it starts talking to the server, and everything happens through that link. So this allows you to start the slave in place that the master cannot see. And while that requires someone manually clicking like the mouse in the browser, once you do that, so this is a GUI program that starts once you do that. But you can install the slave as a, let's say, Windows service so that from the next time onward, it happens all automatically when the machine starts. Now, on Unix, you don't want to there is no such thing as the Windows installer, obviously. So you can achieve the similar effect by let's say, writing etc scripts that executes command like that. So as you can see, it can start establishing connection in many different number of ways. Another thing is the JDK installation, because you have to choose the right JDK for different platforms, and especially because people often use this distributed build to have a necessary number of environments to perform tests. Again, it kind of gets tedious to install the right JDK, and because you have to you have to test your program against a certain version of JDK. Like, let's say if you want to install a new one, you have to download one for Linux, another one for Windows, and another one for Solaris, and so on. So Hudson can install JDK for you. So again, all you need to tell you is that, yes, you agree to the license that we provide. And then you have to tell us the version, and then you can let everything else to Hudson. And it's going to pick up the necessary right binary from java.sun.com, run the installer, provide the necessary binary on the right place before your build starts. So this kind of thing really helps you manage your cluster without spending a lot of time installing tools here and there and babysitting this and that. And the similar thing exists for AMP and Maven. Again, you can just choose the version. Here, you don't even have to agree to the license because their website doesn't do anything like that. So, and this can be also provided by plugins. I think I should pick up the pace. So let's see. So another thing that we do, or another problem that you often have if you start using distributed feature for sure, is that you often have each test. If you look at specific tests, they often need to run on specific environment. So if you have, let's say, 2 Windows slave and 1 Solaris slave, we need a way for you to be able to say, well, this Wombat Windows test needs to run on Windows machine, because it doesn't make sense to run Windows tests on Solaris. So natural instinct, the natural instinct is to say, well, this machine needs to run on slave A or slave B. But if you do that, it kind of is, it's somewhat easy to develop a conflict that reduces the resource utilization. Because let's say if those 2 tests happen to be running at the same time, just because they needed to run on Windows, I guess the people who configured the job randomly chose to run it on Windows slave number 2. And so one of them has to wait for another one to complete before they can proceed, even though there was another Windows slave number 1 that's doing nothing. So it's suboptimal to tie a job to individual machines. So Hudson provides the abstraction called labels, so that you could say those Windows tests are tied to a label Windows. And the administrator could configure the slave size so that they could say, well, these slaves have these labels. So that gives Hudson additional flexibility in scheduling, so that if the Windows number 2 is busy, they could shift the workload into the other Windows machines and so on. And also, or if you have more computing power, and if your build is still taking longer than it should, you could run them in parallel. So often you don't want to do this on the same machine because it could result in some conflict and so on. But if you have enough capability, you can do so. And this allows you to isolate each changes into individual build. So if you don't, so this might actually allow you, even for a big project, it might allow you to test 1 commit at a time. So that makes it really easy to detect regressions in your test. Or if some of your tests are flaky, that is, they flip from success to failure for no apparent reasons, this kind of setup would detect it much more quickly. So it's very convenient. Hudson also helps you monitor the machines. So if you have a large number of machines, again, some of them would develop some problems. So one of the typical problems is that the disk space goes out of space, or you fill up the temporary space, and then it starts to break the builds. So Hudson will periodically monitor those things, like the disk space and the response time. And if they go below a certain critical threshold, they automatically remove the machines from the cluster so that the administrator can work on it. And so in this way, the builds, even though individual machines aren't particularly reliable, the cluster as a whole would function all the time. And it prevents builds from breaking because of those reasons. And then one more thing that Hudson does, one of the many things that Hudson does, is to actually clean up the mess after the builds. So I work in the part of the Sun that develops the application server. So testing it often involves in forking these daemon processes in the background and doing some work with it. So if the test doesn't shut down cleanly, those daemon processes keep running, and eventually they eat up all the memory, and it sort of, the machine becomes unresponsive. So in Hudson actually keeps track of all the processes that you forked from your build. And if the build is finished, even abnormally, it can list all these processes and kill them. So this is the kind of thing that helps you, doing the grunt work of going into the machines and killing unnecessary processes. And it helps you maintain the clean cluster. And you could also monitor where how the machines are utilized. This is taken from one of the big Hudson deployment that has about capability of executing 80 different things concurrently. You can see that it's more or less, I don't know, maybe 20 or 25% utilized. Right? So that's one. And there's actually one more line that it's kind of hard to see here, which is the number of things that's waiting for the available computer to carry out the build. So in this machine, because it's very underutilized, you can see that there's really nothing waiting. Every time someone wants to do another build, then it automatically gets started right away. So here I have a small dent here, which means I think someone submitted a fairly large number of jobs at the same time. So you can see a big spike in the utilization, and some of them are also put in the queue, presumably because maybe there isn't the right kind of slave. Let's say maybe the test needed to be run on Windows, and there wasn't enough Windows machine to do it. So they had to stay in the queue for a while. Now, this is taken from another Hudson that's much smaller. It's only capable of doing 4 things at the same time. And so here you can see that it's almost always fully utilized, and there is something always waiting in the queue that's to be executed. Now, this is a kind of Hudson telling you that it's time to buy one more machine. And so, this kind of information is not only useful for people, but it's actually also useful for Hudson itself, because nowadays with all this cloud computing and so on, you could actually provision a new machine without physically installing them. So we wrote this EC2 plugin, which actually looks at this graph. The Hudson looks at this graph by itself, and it notices that, I have more work to do than what I'm currently capable of. So it could actually notice that, I need 2 more windows, so let's fire up those 2 more windows. And then it does that by talking to EC2. So, and then also if the machine, if it finishes using it, it could automatically trim down the additional capacity. So you can sort of, like in the crunch mode right before the release, you can get additional capability provision from the cloud services like that. And if the release is over, you could get rid of all of them. So that's the kind of thing you can do. And I guess this is the illustration, but it's kind of hard to see, so let me skip that. And then so I started experimenting with EC2 a little, and I have to say I kind of like it. So I did a bit more. That is, so this allows you to run slaves on EC2. That is, you still have Hudson master here, and that's the one that talks to EC2 and get additional power, computing power on the EC2. But I thought, some people might even like the idea of running the entire Hudson cluster on EC2 and not own anything on local workspace. So I developed this little GUI tool that starts the Hudson on EC2 with the right kind of configurations, like the data properly persisted and whatnot. And so then you can also obviously provision the slaves from EC2 and so on. So if you are in the kind of places that extensively rely on EC2, this kind of wizard might be useful. And then there's just a whole bunch of things that I can't possibly cover in 1 hour, like the ID plugin that people have been developing for all the major 3 IDs. Some people wrote the iPhone app and Android app and so on. I guess they can't escape from the fading build even if they're at home, if they have that, but that's their problem. We have the REST API and the CLI, so that if you need to have bigger automation that involves Hudson as a piece, let's say maybe you have a release process that needs to do some work, partly using Hudson, then you could do those things. We have some sort of preliminary deployment automation, so we could say, let's deploy this on the application server for acceptance testing. You could do that. And another front is, because you have this cluster of machines, it'd be nice if you can use this cluster for more than just doing builds. So we developed a plugin that lets you also use this cluster as a Selenium grid, for example, which is often convenient because to test a certain browser, you need a certain operating system. So it's kind of works very nicely with Hudson. Or you could also deploy a Hadoop. Let's say if you want to do large-scale, somewhat large scale data mining on the test failures, you could also use Hudson as a Hadoop cluster, and Hudson would help you install binaries and deploy and start and whatnot. So hopefully I get you interested in Hudson. I think it's fair to say that the continuous integration is here to stay because I don't see anything changing that, because using a lot of PCs, I think is here to stay. So the CI, I think, is one of the main drivers in that direction. And as I hopefully showed you in the demo, Hudson is very easy to get started and get going. And once you start using it, there are a lot more you can do with it. So hopefully you'll be able to try that if you haven't, or if you are, hopefully you find some new use to it. And I think that's it of my talk. So I guess thank you. Right, okay, so the question is, if you're in a startup, you don't want to own all these hardware. I think that's one of the reasons this cloud computing is rather interesting, because you could actually, it's a pay-as-you-go, right? And it's often, so you don't actually have to own the hardware. You could just, let's see, how much Amazon charges nowadays? I think it's 10 cents per hour, was it something like that? So it's very reasonable. Okay, yeah, so the question was, are there other service providers that provide Hudson as a service? Let's see, so I believe, I think there's a startup in London that's developing Hudson-based the software as a service offering. I don't know if they are actually publicly doing it or not, but it must be their plan to do so. On the other hand, it's kind of tricky to provide something like Hudson as a service, a software as a service, because often for any non-trivial project, you have to really control the environment that you run it. So let's say maybe, like if you talk to startups around here, they might say, oh, I need to, because the operation guys want that this, the software we run on this version of Linux with this modified Python on it. And you just have to have that environment to be able to test it. And this SaaS provider is just not going to give you that kind of control. So in practice, I find it a bit tricky. In my personal opinion, I find it a bit tricky to be able to host it, other than in the Amazon model, which basically give you the whole box, right, and then charge for the time. But we'll see, right? Because at least some people are trying it, so we might see it at some point. Yeah. And at one point, Sam was also thinking about doing this, although with everything that's happening, I don't know where it is now. So that's the way I see it now. So how many people are working on core Hudson container, meaning like the portion below the plugin? I think it depends on how you count. I think I can think of at least maybe 3 or 4 very active people who must be doing it for their day job, or else it doesn't explain their commit behaviors. And then there are all kinds of people that just commit like one-off patches. And that's, I kind of like it that way, because if you have to discuss very big change, it takes a lot of overhead. And it's kind of painful to do that, right? But if people are just fixing one bug here and one bug there, that's fine by us, and it helps the quality. If you include those people, I think the number will go up substantially. I think of those 230 people or so, I think at least 40 or 50 people must have committed to the core once. So that's the kind of drill down, I guess. So let's see. So the question is, how do you really correlate the builds and tests? So yeah, so it doesn't actually have to be the downstream. So the mechanism it does is everywhere you want to care about, everywhere you care about what binary you are producing or using, you ask Hudson to record the MD5 fingerprints of these files. And that's basically done by specifying the file globe syntax. and then Hudson will record the checksums. And if the file of the same checksum shows up in multiple places, then they must be the same file. So in that way, it doesn't really have to be related in the upstream downstream relationship. It could happen like a year apart on two entirely unrelated projects, but it could still detect that they are using the same thing. So that's how it does it. Okay, so the question was if I have now I showed you the delta of the defined bug issues, and does it also show you a graph? Yeah, it does. Yeah, so you can see like up and down and so on, which again, it's nice for managers and so on. Yeah. And I think, in fact, in NetBeans, they developed the integration so that you could download this find bugs report from Hudson, and then you could show it overlaid on your IDE, so that if you want to actually fix those problems, it'd be much more convenient than like seeing the reports just online and typing it in IDE. So that's the kind of thing you can do. Okay, so if you run the test after the build, how do you find the build that you want to test? So there are actually several different ways of doing this. The one that I often do is to just test the latest successful build of the binary of the build. And because I'm running both of them continuously, they end up testing pretty new stuff. And I have this tracking that by fingerprint I can see what's being tested. And so that's ideal for the continuous testing environment where you just want to always test the latest stuff.
But how does it find a binary from the build?
So because Hudson provides a permalink, so there's a URL that always points to the last successful jar file that you archived. So that you can do. But the test team often prefers to be able to upload the stuff that they are testing, because let's say they are asked to test this stuff or that stuff. So you can also do those things in Hudson that, well, I'm going to provide you the file that you want to test, and then it provides a GUI to let you choose the file and upload and so on. So that's another way of doing it, and some people do that too. Okay, so I see. So the question was, so you want to keep the records, but just not the archive. So yeah, so there really isn't anything built in that space. The only thing we have is like only keep the last one and throw everything away, which is pretty draconian. It works for CI, but not for anything else. We also let you selectively keep all the artifacts from a particular build if it's important. Like let's say if the build is promoted, that plugin automatically marks the build as important. So there are something in this space, but I think this space can be explored more by writing more plugins. So is there a manual or a book? I believe I've heard a number of times. So I know one or two guys that always seems to be thinking or is writing a book, but I don't know how close he is to the completion. I think the way it must be going with this person is that if he finds something else to do, he does it, and if, let's say, his contract work gets low, he comes back to the book work. So I think if the economy goes down for a while, then we might see a book. I know that there is a German book, but and I've been suggesting them to do translation, but I don't think that has happened yet. So that's the book state. The manual. Aside from so we have those inline help for the configuration items. So that hopefully could be considered as a manual. We have a wiki site that sort of captures some of the major topics, but there's no such thing as enough documentation, I guess. It certainly could be improved more. Yeah, I guess that's sort of like the state of it. Okay, so any plan that does rollback, I think one of the experiment that we are doing is sort of let you upload the diff as a part of the build, and we check out the source code and apply the diff and then run the build and test and so on. So that's a way of testing stuff before you actually commit it to the repository. Can I roll back things after you notice that the build is broken? I think it's filed in the issue tracker, but I don't think it has been implemented. What's the feature that I'm working on? Good question. I think oftentimes it's basically driven by bugs and feature requests that's being filed. And other times I just have to, let's say, review someone else's patches. So that often wastes time. But in terms of big ticket items, let's see. So what would be? So I don't really have any long-term plan. It never really had any long-term plan like that. But So one of the obvious thing is this pre-tested commit feature that's been requested a significant number of times. I think it's #1 voted issue right now. So a better integration to let you upload the change and let Hudson run the tests and tell you whether it was good or not. That's something we'd like to work on. Another thing is that we want to put more intelligence on the output from the console. So let's say if you're looking at the shell output from your build script, it's sort of like you might see a line that says the test failed and error is #5, but it'd be like I thought it'd be pretty nice if you can click that 5 and see the 5 failures. You can't do that in Terminal, but in Hudson you should be able to do something like that. Yeah, or stack trace. Yeah, so if you see a stack trace and if you can click that line and jump to the source code, that would be mighty handy. So that's the kind of thing that I'd like to do, and I'm working on it. So is Oracle paying me to do this? Yes. Yeah, and so yeah. And so the part of the reason, I guess, so we are offering this commercial version of Hudson, and that's sort of a part of the way for it to help me getting paid to do this, I guess. But the majority of the effort, I think, is done by the community, and I believe they are just scratching their own itch because they are using Hudson and they can write the code, and they see some behaviors that they didn't like, and so they just fix it. So I'm quite confident with the long-term sustainability of the project, even if no one is interested in, hiring someone in the full time. But Oracle does pay me full time to do this. Okay, so can you have 2 machines, one for just doing build and another for just doing tests? Yeah, you can. So let's say you might use, if you only have 2, you might just say, well, this job needs to run on this machine, and those test jobs need to run on that machine. Or you could use the label that I explained to you earlier, and you could say, well, all the test jobs needs to run on the label test, and these are the machines that's in the label test, and all the other ones, and so on. So you could do those things. Oh, I see. So I think the question really more is like, if you want to run a portion of thing on one machine, and bring everything over to another machine and leave it, continue it from your left off. No, that's not, well, so you could sort of do it, but it's not as easy as it should be. So you could upload, you could archive the entire workspace, and you could have another one download that workspace as a zip file and extract it and so on. But so that involves some more manual setup than ideally you can. Because ideally you just say, just this job would inherit over from the leftover from the earlier one. So yeah, that's actually another feature that's very commonly requested. I think I'm sure it's within top 5. So yeah, I hope to be able to do something like that. Is there a Selenium resource with integrating Selenium? Yeah, so there are actually 2 or 3 different plugins with Selenium. I actually can't keep up with all the different flavors of Selenium. They seem to be coming up with different ones, but I know for sure that there's one that integrates the reports. Then I know, well, I personally wrote another one, which is basically about deploying Selenium grid on top of a Hudson cluster. So if you have 2 Linux slaves and 1 Mac slave and 2 Windows slave, and you could say, well, give me IE on Windows, and the Hudson would find the right machine and start machine, and the programming model is the same Selenium. So there's that, and I think there's a few more, but I haven't really looked into details about what they do. So yeah, so there's a pretty decent integration with Selenium. Okay, so thank you very much, and I guess that's it.